So with the analysis during the previous few slides, we can establish a foundation for making equivalence analysis by using effective interest rate. Again, going back to what we said before, we need to have an interest rate so that we can compute equivalence. And this interest rate has to be able to capture the form of the pattern. So what we need to deal with is we may be given a nominal rate which is based on the annual payment, but most of the time we are not dealing with annual payment. So we need to convert it to the effective rate precisely for the payment periods, so that we can utilize the effective rate combining with the payment to compute, to deal with the conversion of the equivalence. So there are three steps. By summarizing the previous few slides, there are three steps that we can do. One is to identify the payment period. Okay, we need to know what's the period for the payment. Then we need to identify the interest period. Okay, and then we need to compute the effective interest rate that covers the payment periods. The payment periods will be where the cash flow happens. So we need to be able to find precisely the effective interest rate of the payment period, or each of the payment period, so that we can convert them and result in equivalence. There are different cases. Okay, there are different cases when we are finding the effective interest rate that covers the payment period. Case 1, which is the simplest one, that is a compounding period is equal to payment period, identical. So we don't need to deal with too many things. Case 2 is compounding period is smaller than payment period, which we have seen. So for the payment, within the payment period, there could be multiple interest period. The third case, just the opposite of the second case, where compounding periods is greater than payment period. Okay. So either way, for case 2 or case 3, we need to be able to convert the interest rate, effective interest rate, so that it will cover precisely the payment period. So if we look at first case, again, this is the simplest case where the payment periods and compounding periods coincide. So we just need to use either a payment period or compounding a period as a basis for computation. Let's use a very common case to illustrate this the conversion. I think more or less all of you will take on some loan. That is, for example, here if you are buying a car, so you will take auto loan. And auto loan is usually given when they are lending you the money, or they are allowing to do this financing for later installment of payments. They will quote you an interest rate. That interest rate is usually the nominal interest rate for the year. And however, the compounding periods will, just like most of the other cases, will be monthly. And for auto loan, usually the payment periods will be monthly too. So the payment periods and the interest period or the compounding periods will be the same. So we'll treat them. We can deal with them together. So let's just say the car that we are buying, invoice price is $21,599. There's a sales tax. There's a dealer's freight cost, and which are a percentage of the car price. So you add them together, which come to 22,678. And then you pay a down payment, which is 2,678. The remaining part of the purchase price will be 20,000 left. Okay, so 20,000 is something that we need to pay back. Only pay 2,678, but the price of the car is 22,678, and the dealer's interest rate, which is the nominal rate, is 8.5%. And length of financing is 48 months. So 48 months. For 48 months, every month you need to pay a fixed amount back to the auto company or the dealership or the bank. And the interest rate will be compounded monthly. So we'll see how that goes. So remember the cash flow diagram. Buying the car, you borrow 20,000. 20,000, that is what you need to pay back. And you need to pay 48 equal installment back to the loaner. So your principal, the present value is 20,000, and the interest rate is for the year. You have 12 payments per year. You have 48 total payments. So what you can do is, first you want to compute the effective interest rate per month. So you take step 2, divided by 8.5% by 12, and that's the interest rate per month. And you have 48 months. So now you can compute A, because they are of equal payment. So A will be equal to 20,000, which is the present value. So you are given present value 20,000, and you want to find A, 48 equal payment, and the interest rate for the periods has been computed above, which is 0.7083%, and in total we have 48 periods. And within this symbol, we can look up from the table in the back of the textbook, or maybe we need to do a little interpolation so that we get a precise number or a closer number. Multiply 20,000, we get 492.97. So 492.97 will be the amount that we will pay every month at the end of the month for 48 straight months. Okay. And this 492.97 payment for 48 months, the value of it will be equivalent to 20,000 at the present time, at the annual interest rate of 8.5%. But if you want to express it by effective interest rate, it will be 0.7083% per month. That's the effective interest rate for the payment period. Okay. Of course, you can compute, based on this, you can compute effective annual interest rate. but this is basically a lot of time that we will use. You borrow money and you need to pay the money back in equal installment over a period of time. You can compute the right effective interest rate for the payment period so that it can compute precisely what payment that you need to prepare for the duration of the payback. Another example that we have here is an interesting one. Sometimes we tell people that, oh, if you started to save the money frequently for a long time, it will accumulate into a large sum. It's not just the accumulation. It is also the interest that is included and compounded over time. So let's just take this cigarette smoking case. Assuming that the cigarette price stay the same, $1.75 per pack, and over a 50 period, if you instead not smoking a cigarette, deposit the money in the bank, so over a 50-year period, what will the result come to? As usual, we need to have the right representation of the interest rate. Assuming that the annual interest rate is 5.5%, then if we calculate using earlier equation, we can know that if we smoke a pack a day over 50 years period, if we deposit the money that we spend on the cigarette weekly, it will come to $169,000, close to $170,000. If we smoke 2 packs a day, it will double that number, and so on. So how do we compute this? In fact, it's just quite straightforward, just as we did previously. We have this 5.5 annual interest rate. We cannot use it directly because we put the money to the bank every weekly, and the interest rate, effective interest rate, will be compounded every week. So if you put the money there weekly, and then and we take this annual interest rate divided by 52, so come to the interest rate every week. Okay, so again, we are assuming that the compounding period and the payment periods are the same. So then we know that we assume that we smoke a pack of cigarette every day. So 7 days we'll smoke 7 packs times 1.75 dollars per pack. So every week we'll save $12.25, and then we'll do this saving for 50 years. So 52 weeks times 50, we get 2,600 weeks. So we are going to find the value at the end of the 50 years. So after 50 years, if you gave up smoking and instead save the money to the bank every week, and the amount of money that you will get or will see at the end of the 50 years. So we use A, which is a weekly deposit, right? 12.25. Given A, find F, and the interest rate for the period A, the weekly interest rate, which has already been computed above, is 0.1 a little bit more than 0.1%, and the duration of the accumulation will be 2,600. So again, you can try to find this coefficient from the back of the textbook. If you can also use the equation, the formula that we have discussed earlier. You can just compute it directly and multiply by 12.25, and you'll get the numbers. When the payment periods are different from compounding periods, then we have to go to the process that we have described previously. We need to involve using this equation, having number of interest period per payment period times number of payment periods, okay, to get the total compounding period or interest period over 1 year period, over 1 year. Then we'll take the power of number of interest period per payment period, so that we can obtain the effective interest rate for the payment period. If the compounding is continuous, then we will need to use this equation to get the interest rate directly. So basically, following exactly the same process, we can get the solution. So we can also look at an example, which is on the discrete case, not the continuous compounding case. Here we are assuming that we have this quarterly deposit, but still with monthly compounding. So over the course of a year, we'll do this compounding, interest compounding every month, but we will only deposit every 3 months. So C equal to 3, okay, because each period is 3 months. Within that 3 months, we have 3 interest payment, and the payment periods for the year per year will be equal to, will now be equal to 4. So in total, 3 times 4 equals to 12 compounding periods per year. That is 12 months. So we can easily apply the equation we just showed, and we can get the effective interest rate over the payment period, which is a season or 3 months, will be 3.03%. And it's over 2 years period. So we have 4 payment periods in 1 year. 2 years with 8 payment periods. So if we want to know this sequence of deposit at the end of the 2 years, how much money that we are going to get back, then we can use an earlier formula that we introduced. The future value of this series of equal value can be found by multiply this equal value, which is 1,000, times given A. This is A. Find F. This is what we want to find, and the effective interest rate that we are using, effective interest rate for the payment period. Right? Just originally there were supposed to be 3 different compounding periods. We have already combined them into a single effective interest rate, which is 3.03%, and for 8 periods, as you can see, and we can get this value. So it's relatively straightforward to do the conversion for the equivalence. If the compounding is continuous, as we also showed previously. We just need to involve this formula. So we plug in R, we plug in K, and we can, R is the nominal interest rate, annual interest rate, so it's 8%, and we have 4 payment period, K equal to 4. So we can get the result directly, which is 2.02% per month. Okay, and we have that for the payment period. The payment period is the effective interest rate is 2.02, and then in this particular case, we went through 5 years. So in total, we'll have 20 payment periods. Okay, 20 payment periods. So use 500 given A, which is 500, find P, and if we want to find P, and this is interest rate, this is number of periods, and we get 8,159.96. Okay. Okay, so when it comes to the compounding periods, the number of compounding periods is less frequent than payments. So you have a much longer compounding period, right? And then what we need to do is we still need to compute C, okay, which is for each payment, what will be the number of compounding periods. Here, since it's longer, so C equals to a value that is smaller than 1. But it's just a number. We can still take the number and plug in this formula, and we can compute that the interest rate will be 0.826% per month. We can still obtain that. And since we have that, and then n total number of compounding period will be 12 times 10 years, so we have 120. And again, using the formula, we are given A, we want to find F, find the future value, and we have this effective interest rate for the months and 120 months. So we can again using the lookup table or compute it directly, and then we can get the final result. Now we can look at a more comprehensive example. Credit card debt. I think, I'm not sure how many of you have credit cards, but I think it is a financial instrument where you can utilize the card to make purchase, and if you can pay off the amount that you spend, your cost could be relatively low, and because it's just like something that you can just swipe and things will just happen. So there were also a lot of people overspend their credit cards. The biggest problem of the credit card for these people will be most of the people did not know that the kind of cost, the kind of interest that they are paying on the credit card. So they just feel that they can spend the money as they want, and they can just pay back the money later on, and they thought that the payback shouldn't be too bad, and maybe we will look at that so that it also illustrates the power of the interest, the compounding power of the interest. When the problem continue to accumulate, then over a long period of time, it becomes very significant. Okay, so let's look at credit card. Usually for credit card, there are different kinds of parameters that we need to know. For example, some credit cards have annual fee. You need to pay upfront certain amount so that you can use the credit card. But then again, you can just use the card at places where they accept credit card without any money. Of course, you will need to pay back money that you spend on the credit card. Okay, and you have annual percentage rate, which is an interest rate, and this interest rate sometimes get a little bit complicated and a little bit confusing. But in general, it could be a certain kind of rate that you use to compute the interest that you need to pay. There's something called grace period. That is, after you receive, after you spend the money, after you receive the bill, there's still some period of time before you need to pay back what you spent. Okay, that's grace period. Once you exceed the grace period, then you need to pay interest. But how to compute the interest that you need to pay depends on the arrangement. And usually a credit card company will specify a minimum payment. So every month you spend a certain amount of money. You can leave a lot of them not paid, but you still need to pay minimum payment. If you don't pay the minimum payment, you will get fined. You will get even higher costs on your spending, and you will have so-called financial charge. That is your interest if your payment exceeds grace period, and also if you basically exceeds the grace period because of the interest rate shown there. You don't need to pay them off, but for unpaid part, you need to pay, not necessarily unpaid part, depending on the arrangement again, you will need to pay interest. So we can look at the below example to see how prevalent the or how severe the problem can become if you don't pay off your credit card debt. For example, if you pay every time you're charged with, you have spent a certain amount of money and you only pay 2% back. You only pay 2% back, and it will take 27 years, 2 months to pay them back, all of them back. And if you want to know, for example, $2,705 of credit card balance over 20 years, 2 months, you are paying the interest and returning the money at the same time. You are paying 11,000 more of the interest. If you're paying back higher percentage of the balance, then you will pay off your debt within a much shorter period of time, and still you are paying a lot of interest. Okay. With respect to just $2,705, if you paid it too slowly, you can be paying 11,000, more than 11,000 of the interest. Okay. Almost like 4 times, 5 times, 4 times of the money that you owed. So it's tremendous. If you are owing 5,000, if you are owing 10,000, you can imagine the number is quite significant. So when you are spending your credit card, you have to be very careful about the arrangement. What is the annual fee? What is the annual percentage rate? What is the grace period? And how does the interest or how is the interest computed? That you need to know. Otherwise, you could be paying a lot of interest just because you are overdue. Your payment has already passed grace period, or you only pay minimum payment. The rest of them you leave them and paying the interest. You have to understand how these are done. So there are different ways of calculating interest on the credit card. At least you can see these three. One is the adjusted balance. So you have returned certain pay back certain amount. The remaining part you will be charged with the interest. That's one possibility. The other possibility is you have returned certain amount, and then they take on certain date. So they take the period and compute the weighted average of the total amount and the amount that you have, amount that is still remain to be paid, and add them together. In this particular case example, you can also see that because it's returned in the middle of the month, so 50-50. So you take 3,000 and 2,000 and divide it by 2. You have average 2,500 you owed, multiplied by 1.5% for the month. It could also be so-called previous balance, so they don't care how much you return. Once you haven't paid back all of them, they will just charge you for the full amount that you spent. Okay, that's previous balance, so that would be the highest one.